Sir, 16 rupees. 16 rupees.
Hello. Can you hear me?
Balance.
Yes, ready, sir.
Customer waiting. Then balance 16 rupees.
Correct, sir.
So we'll wait for some more time for the people to join, okay? Let me record the screen and let me share the desktop. So just write, if you have any questions, just raise your hands or just write, call me. Just in the morning I was explaining about the segmentation in the memory, right? Why do you want to segment the memory? So I was talking about, there is 20 lines we have. So that's what the size of the address bus is 20, which means that I should be able to address 1 MB of physical memory. Okay. So what since we have only 16 bytes, 16 bits of data, which means that I can probably address only 2 power 16 at once. That is what the maximum address I can allocate. So what they did is they segmented the 1 MB memory into 16 segments. Okay, so 64 kilobytes is where I can address. So that is what I can do by using segmentation. I think I can just show how that segmentation is happening and how the offset is used for moving the data, managing or moving across the segments. Okay, so the address of the segments may be assigned as, so from 000H to F00H. This is what the addresses of the segments looks like. Okay, and the offset is from 000 to F. This is what. Okay, so just have this. I think I can show you how this is been done. So leave this. So these are the segments we have. So we have code segment. I think out of that 16 segment, these are the 4 segments which we use for the programming. And in the context of your whenever you run a program, these are the segments which will be used for executing your program. Okay. So we have 4 segments. One is the code segment. So the associated is the instruction pointer. Okay. So with the code segment and the instruction pointer, I should be able to locate my the code to be executed. Okay. So the data segment plus the source index, that register will help me to locate the data which I'm going to process. So the extra segment and the destination index helps me to get the global data. Okay, there are a lot of data types are there, right? Local data, global data, static data, right? So those are the extra segment which will help me to get the global data. So data segment will have the local data. So we'll come to local data, global data when the programming. So when you have a variable defined inside a function, it is called an automatic variable. I hope you might be heard about the term. Okay, so which is above. If you declare a variable as a global variable, that should be viewed that can be viewed by all other functions in that file. Okay, so that is the extra segment where I have all the global variables sitting there. So the stack segment will help me to stack segment plus the stack pointer or a base pointer will help me to locate, push and pop the data. So suppose if I'm calling from function A to function B, so the function A values will be pushed, right? Return address, everything will be pushed, and then the code. Ideally, I am jumping from one instruction, right? One set of code to another set of code. Okay, that is where the jump instruction comes in. So when you do a function call, everything will be pushed onto the stack, and that is called the processor status word, PSW. That will be saved. Everything will be saved onto the stack, and then the control will goes to the called function. Okay, then the execution will happen. And again, when the return comes in, when you do a return, I'll pop the value from the stack pointer, from the stack, using the stack pointer and the stack segment, I'll pop the value, and then I'll return to the from where I left. If I'm calling from function A to function B, once the function B completes, it has to return to the next instruction in function A. That's where the stack segment plays an important role. And there is the stack segment and the register, offset register, will help you to locate exactly where the data has to you have to manipulate. So any questions so far? Any question? So so within maximum you can address 1 MB in 2 power 20 is 1 MB. So that is the unique address physical memory lines you can have. Okay. So in that I have said that maximum there are 16 such segments you can create. So the important 4 segments are code segment, data segment, extra segment, stack segment. These are the 4 segments you have, which is each segment can have 64K of memory. Okay. So the 4 segment registers are used to point to the beginning of each segment, which means, so if you say that you have a segment, the code segment will have the beginning, the first starting point of the segment address. So code segment, say suppose 000, it is the starting address of the code segment. Data segment will be having 0 plus 64. I think 65 is the starting address of data segment. Again, if you add another 64, you'll get, I think I'm taking an example. So this is how the starting address of the each segments will be there in the, or the first location will be there in the code segment register. Okay. And with the use of the instruction pointer, or if you look at in this, right, with the use of this register plus this segment, I'll add these two to get the actual address of the code or the data. Okay, so this is where so the 4 segments need not to be defined separately; they can overlap. So that is where the concept comes in. Okay. So how the memory addressing happens? So there are something called a logical address and physical address. So addresses within a segment can range from 0 to FFFFH. Okay, this is what each segment. So from 0 to, say suppose you say 64 is the value in terms of numerical value. Say 64K. So this is what in terms of hexadecimal you say FFFFH. This is what the maximum value which I can hold in a segment. Okay. This corresponds to a 64K length of a segment. An address with a segment is called an offset or logical address. An address with the segment, okay, within a segment is called an offset. So if you say segment, code segment, the code segment is where I think when I say a code, so the code will be residing inside the segment. In that segment, where exactly the code is, that is the offset. So from the base address, if you add this offset, you get the location of the code. Okay. For example, say the logical address is 000F. So this is 000F is in a code segment. So suppose the code segment is B3FF. Actually, the real address is, you add the base address, this is the value which is there in the code segment, plus the offset. If you add these two, you will get the exact address of the data or the code. Okay, I think ideally it is a code or data which depends upon the. So the physical address is 24 bits long and corresponds to the actual binary output of the CPU. So the logical address is an offset from the location 0 in a given segment. Okay, so that is what you need to. So whenever you say, I'll probably mention the logical address. When you want to get a physical address, you will add up to that segment which segment you are in. If you are in a code segment, you take the code segment value plus you add the logical offset value, and then you get the physical location. Is it clear? நம்ம புரியுதாப்பா? ஏதாவது யாராவது சொல்லுங்கப்பா. என்னப்பா பேசிட்டே இருக்கேன், சத்தத்தை காணோம்.
Yes, sir.
How are the others? So I see only Lourdraj in the call. Okay. So it is a 9. Yeah. So let me probably have another PPT. I can just explain this. So 1 second. So the total memory size is divided into segmented various sizes. A segment is just an area of memory. The process is the process of dividing memory is called the segmentation. Okay. So in memory, data is stored as bytes. Each byte has a specific address. Intel has 8086 has 20 lines address bus. Okay, with 20 address lines, the memory that can be addressed is 2 power 20, which is 1 MB. 8086 can access memory with address ranging from, so which means that 20 instance you have 1 MB, 000 is, say suppose take 8, 1, 2, 3, 4, 5. Okay. H to FFF. This is the maximum address range I have in the memory. So in the memory segmentation, you have code segment, data segments, stack segment, extra segment. These are the 4 segments you have. So each segments are addressed by an address stored in the corresponding segment register. These are 16-bit size. So each register shows the base address, starting address of the corresponding segment. Because the segment registers cannot store 20 bits. So this is what I was telling yesterday in the morning, because we have only 16-bit registers. So I cannot store a 20-bit value. That is why I use the segment and offset for arriving the physical address. So if you look at, so this is the memory. Okay. So code segment, I just have like this. Data segment, I just see this is the starting address. Code segment will have the starting address of the code segment. Data segment will have the starting address of the data segment. Stack segment will have the starting point, and the extra segment will point to the data part. Okay, this is how the memory is segmented. Okay, so how a 20-bit address obtained if there are only 16-bit registers? The answer lies in the subsequent slides. The 20-bit address of a byte is called its physical address. Okay, the 20-bit address is called a physical address, but it is specified as a logical address. The logical address is formed by 2 values. One is the base address plus the offset value. So offset is the displacement. Displacement is what I mean is displacement is, so this is the starting point. So when I say a displacement is, this is the value I'll give. So from here to here. So I don't tell, say suppose this is 0000. Okay. Say 1000. This is 1000. And I'll say only 10. I don't say 10,000 or 1010. So if I want to address, I say in the code segment the value is 10. So when how exactly that is converted? So they add the base plus this 10, then they will come to this location. And if I want to take a data, say that the data is in 20. Okay, so immediately what the BIE will do? The BIE will add this starting address plus the displacement and then get to the data. Okay, so this is how the 16 to 20-bit conversion happens via the logical address. Okay, the offset is the displacement from where, right? How long from this location to this location. So if say this is the location, so from here to here, I just only tell the number. I don't add up sum of these two. Summing up of these two will be done by the BIU. So here the example, the value of data segment register suppose is 2222H. Okay. To convert this 16-bit address to a 20-bit address, the BIU appends, which means that it left shifts by 4 bits. Okay, the 4 bits, what I'm talking about is the extra lines. Okay, you have 16 bits is the data bus and 20 bits address bus. So what I'll do is I left shift this value, and then I'll say, which means the left shift there will be a 0 added to this data segment register. Okay. After appending the starting address, which means the data now will become 2222 Okay. So this is what they're telling. They're appending a 0. And then if the data at any location has a logical address specified as, so I don't specify this 2222. So say this is a displacement I was talking about. Okay. 0001x. Then the number 001x is the offset. Okay. So 2222h is the value of data segment, and 0001s is the offset value. With these two, to calculate the effective address, starting address of the segment plus the offset. To find the starting address of the segment, BAU appends the content segment register with 0h. Okay. Then it adds the offset to it. This is what I was talking about. So this is the value which would be the 222 will be the value will be there in the code segment, and then you append a 0. Effective address is you append the 0 and you add the offset. If you add the offset, you will get 222236. This is the actual physical address of the data or the code what you are referring to. Is it clear? So this is the right base address of the data segment 2222, and from 0 it goes like this, and the offset I say 0016. So I left shift this, or I'll add a 0 to it, and I add these together, and I'll get the value in the 16th location here. Okay, this is a displacement value. This is the base value. When I add these together, I'll get the exact location of my data. So all offsets are limited to 16 bits. Okay, so I cannot go beyond, because the memory which I can be addressed using the 16-bit is 64K. So the offset of the first location within the segment is 000. The offset of the last location is FFFF. Okay, that is what the value could be. Okay. So these are the combination of the registers where I can find the code segment plus the instruction pointer will get me the next instruction. Data segment plus, right, the BS or the data index. So the destination source index will get the address of the data. So stack pointer, the combination of source, right, stack pointer plus the stack segment will give me the physical location of the stack. Extra segment will get me the string operations or the global variables where I define in a program. So these are the combination of values, registers, which help me to do these functions. Okay. We can just answer this, right? Content of the following registers are: CS is CS is 111H. Calculate the corresponding physical address of the address in the CS, DS, and SS. H 333H. So the base address of the code is 0000H. Effective address of the given memory is, so I think they haven't given it. So instruction pointer, I think code segment is this. If you add these two, you'll get the instruction value. Data segment plus the destination index will give me the value. So we have to add these together to get the exact location. Effective address is, so in here code segment plus instruction pointer. Code segment plus instruction pointer will get me the effective address of the memory. So this is how they arrive at this physical memory to logical memory. Okay. So any questions, guys? So with this Monday we can again meet, and then we'll probably go through the programming exam, because I see only a couple of people in this meeting. So let me stop here so that I can continue on Monday. So